In this presentation, we're going to look at vertical asymptotes for functions. So it's a straightforward enough idea. We'll have a quick look at it shortly. But essentially, to compute the vertical asymptote, what you have to do is get the denominator of the function. So this is the function x, and get the denominator of the function and set it to 0, and then just solve for x. Okay. So first off, there actually has to be a denominator, and we'll have a look at that shortly. And also the denominator also has to be a function of x. Okay, so we'll look at an example where that is not the case. So let's kick off and just sort of see what is an asymptote. It's essentially, for this function here in black, f of x, as it goes in this direction up here, like that, it gets closer and closer to this red line here, but it never actually crosses it. Okay, so essentially this is a sort of asymptote, a sort of vertical barrier that this function will get closer and closer to, but never cross. That's really it, actually. That's just all the vertical asymptotes are. So let's look at some examples here. So here we have the first one, okay, and here we have the vertical asymptote of this function f of x. And what we're going to do is pick out the denominator of the function, and it is a function in terms of x. So x minus 7, and set that to 0, and then solve for x. X equal to 7, that is our vertical asymptote. That's the answer basically. Vertical asymptote, x is equal to 7. Okay? Another example here, f of x equals x minus 3 over 7. Now, we have a denominator of a function, but let's go back here. It is the denominator has to be a function of x, and in this case, there is no. It's not a function of x. So this is in this case there is actually no vertical asymptote. A function does not necessarily need to have vertical asymptotes. It may be the case that there are no vertical asymptotes at all, and this is one of those particular cases. So in this situation, what essentially we have here is a sort of line. Any old sort of slope line that just goes not necessarily this line here, but it just goes from plus infinity to a minus infinity without any sort of barriers in the way. That there's no sort of, it just goes on in each direction to infinity on either side. Okay, now. So that's a case where we have no vertical asymptotes, but you could actually also have a case where there are two vertical asymptotes. Okay, so this is a case where we have two vertical asymptotes. Essentially what we're going to do here is let x, we get x squared minus 4 is equal to 0. That's our denominator of that function. And let's solve it. X squared equals 4. So we could have x equal to 2 or x equal to minus 2. Okay, so we actually would have two asymptotes in this particular for this particular answer. So that is vertical asymptotes. It's just a quick introduction of all the things that might come up in this sort of exam.